Hi, everybody. I'm Greg Fishel, and welcome to bonus weather video number 1 for this week. And we're going to be talking about hurricanes, where and when and why. So let's get into it here. And we're going to take it month by month. And this is the number of hurricanes you would expect in a 100-year period to occur within 150 miles of any given location. So this goes up through the year 2020. It does not include 2021 and 2022, but in general, you could expect anywhere from 5 to 19 hurricanes in the eastern Gulf of Mexico in the month of June over a 100-year period. Now, we move on to July. A little bit of an expansion here to the Gulf Coast and the Atlantic Coast, and also a little patch down there in the Caribbean. But again, we're not talking about a lot of activity. Then things definitely start to ramp up as we head into the month of August. And you can see this color extension here off toward Africa. So these African waves that begin to come off the African coast then develop once they get into the eastern Atlantic and turn into hurricanes and move off in this direction. So, let me go back there one. That color that you see right there is anywhere from 35 to 49 hurricanes over the course of a 100-year period within 150 miles of any given location. All right, then we move into the month of September, and this is when things peak. About September 10th is the date that we're most likely to have a named system somewhere in the Atlantic Basin. We've still got the African connection here. As you can see, the system's curving up like this toward the southeast coast of the United States and then recurving out to sea. October, the African connection is pretty much gone by that time, and we start to focus our attention more on homegrown systems, if you will, in the Caribbean Sea, the Gulf of Mexico, and off the coast of the United States. And then finally, as we get into November, it really begins to wind down. Still a few that occur in the Caribbean off the East Coast. And again, this is within 150 miles of any location here. So it could be out in this area here as well. Okay, so now we're going to get into a little math, and it may be more than a little, but we'll get through it. So the Earth actually helps to generate cyclonic spin, or what we call cyclonic vorticity, just by nature of the fact that the Earth rotates. Now, the Earth's vorticity is defined by this equation: 2 times the Greek letter omega times the sine of the Greek letter theta, okay? Now, the omega is equal to the Earth's angular velocity. In other words, how many angles or how many degrees does the Earth sweep out in a given day, okay, by spinning around. And then theta is equal to the latitude, which is 0 at the equator and 90 at the North Pole, okay? So, and if you remember back to your math days, pi is equal to 3.1416. There are a whole bunch of numbers that come after that. We're going to simplify it here and just cut it off at 4. So a complete circle is equal to 2 pi, or 6.2832. Now, the number of seconds in a day: 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. That equals 86,400 seconds. So the Earth's angular velocity is equal to 6.2832 radians, which is another unit for degrees, if you will, divided by 86,400 seconds, and that gives us 7.27 times 10 to the minus fifth radians per second. And that minus 5, in case you're interested, all you got to do is that's the number of places you move the decimal point off to the left. So moving it off to the left one position would be 0.727, 2 positions 0.0727, and so forth. So it's just a simpler way to write it. It takes up less space, okay? All right, so a little more math here. At the equator, the sine of 0, which is the latitude at the equator, is 0. Okay, so there's no Earth-generated vorticity at the equator at all, and that's why tropical systems don't form at the equator. They have to be north of the equator a little bit. At the North Pole, the sine of 90 degrees is 1, so the Earth-generated vorticity at the North Pole is equal to 2 times the Earth's angular speed, the 7.27 times 10 to the minus fifth radians a second, and so that gives us 14.454 times 10 to the minus fifth radians per second. So that's how much vorticity the Earth generates at the North Pole. So as you go farther and farther north, the Earth's rotation generates more and more vorticity. And just to break it down for you here, and meteorologists basically take off that minus 5, okay? And so we just look at the number exclusive of that, okay? So the Earth's vorticity at latitude 0 is 0, then it's 2.5 at 10 degrees north, 5 at 20 degrees north, and then all the way up to 14.5 degrees at 90 degrees north of the North Pole. And generally, a good, healthy mid-latitude system has a total vorticity of about 20. So in the mid-latitudes, you could say that the Earth is contributing about half of that vorticity, and then the system itself is generating vorticity, and you add the two up, and that gives you the total value, okay? And then, the last thing I'm going to talk about, if you have something that's already spinning and you converge it, okay, then, or you impose convergence on it, it spins even faster. It's like the ice skater that has their arms out like this. I know my hands are getting cut off, but as they bring their arms in closer together, they spin faster and faster. So convergence, or a smaller radius, makes it spin faster, okay? So supposing we have a front, a stationary front, and there's northeast winds to the north of it and southwest winds to the south of it. That air is coming together, and so there's already vorticity along that front, and then the Earth would contribute even more to that, the Earth's rotation. And then we also have these easterly waves that come off the coast of Africa, and so I put a little dotted black line there as to the axis of these troughs, and so you have a southeast wind on one side of it and a northeast wind on the other side of it, and so the air is converging there, and as long as this is not at the equator, the Earth is going to add some spin to that and add to the total amount of vorticity present. So basically, hurricanes have to form a little north of the equator and south of the equator in the southern hemisphere because that Earth's rotation sort of helps it along a little bit and helps the system to get going. And then other processes come along to make the system even stronger. Okay, that is bonus weather video number 1 for this week. Hope you enjoyed it. We obviously are keeping a close watch on Ian. We'll have many, many more updates in the coming days, and we hope you'll join us for those. Y'all take care.